So, you've taken a challenge, you've tried to make the fastest time and get it to display. So now you're watching this video, and this is where we'll break down exactly how this works. So why would you want the fastest time? Well, it adds a little bit more challenge to your level, because at the minute, when you complete the level, that's it. Level's completed. There's no replayability. And every good game should have some form of replayability, something to get the end user to come back and replay it again. And in this type of game, the easiest way to do that will be like a high score or a fastest time. So that's what we've done. So to do that, all we did was create a simple UI called fastest time. So if I unhide it, it's fastest time and whatever the time is. Let's hide it again, and let's just actually see it in action. So we'll hit play, and we'll just complete the level really, really quickly. We'll complete the level really, really quickly. So the fastest time is 14 seconds. So let's end the game and replay again. And I'm going to make sure that I finish it in a longer time this time, so a lesser time. Sorry, a higher time. So I can take longer to complete the level, basically. So it's 14 seconds, let's just make it 20 here. And the current fastest time is now 14 seconds. So you notice the difference there. What was happening was when we set a new time, that became our fastest time. Now, anytime we are more than the current fastest time, as you're going to say is the current fastest time is X. Whereas if I set a new record, so let's complete this in less than 14 seconds, what's going to happen is it's going to set a new fastest time. So our new fastest time is 13 seconds. So how do we do that? Well, like I said, we create a UI text which is called fastest time, and then we edit our timer script. So let's open that timer script and let's look at what's happening. So we've made a new serialized field and it's called fastest time, and that's the reference to the fastest time text. So it has this text element here. So don't forget, we also need to make sure we're using the Unity engine, not UI, so we can inherit the UI classes. Then we've made a public float and we've called that public float fastest time, and that holds the fastest time. Next step is in the start function, we're using something called player prefs. And what player prefs does, it's kind of like a save game feature or save stat feature. And what we can do is save certain stats in memory. And this particular stat is going to be a float. Now the way player prefs work is it has a method which is a key. So the key is what you call that piece of data. So think of it like a database. So think of like an Excel sheet or a Google sheet. You have a cell which you can have a heading name, and then you have the data underneath that. So let me just bring up a blank sheet. So if I was to go to here, this first row is our headings. Let's say we use it for example. So we've got weight class and then the different types of weights we have in that weight class. But in this instance, what we're doing is we're saying fastest time. So that's our key, which is basically just a heading, and then the fastest time is current fastest time, or 14 seconds, or 15 seconds, or whatever. But that's basically the information that's getting stored there. So that's the key, and that's the information that gets stored in that key. So think of it like a little mini database. So the way player prefs work, if we look at the Unity API, it's a class that stores player preferences between game sessions. It can store a string, a float, or an integer value into the user's platform registry. So it actually says that as a registry. Unity stores player prefs in a local registry without encryption. Do not use player prefs to store data sensitive data. So you wouldn't store stuff like passwords in here, for example. It's only stuff like scores or higher scores that we would use it for. Unity stores player prefs data differently based on the operating system that the application runs on. In the file paths given on the page, the example company name and example production name are the names you set in the Unity player settings, which goes kind of beyond the scope of what we're doing here. Essentially, it's just going to store this in registry. Now, what you can do is you have some static methods. So save, set float, set integer, or set string, and has key. You can also use getters. So these are your setters, these are your getters. So you can get a float, get an integer, or get a string. You can save the player prefs or set float, set in, set string. So what we're going to do is obviously set a float and check have we got a key and save. At some point we also use the get. So let's look at it in the script. So we're saying at the start, if player prefs dot has key fastest time. So if a key exists in our setting, in our player settings in the registry as fastest time, then what we'll do is set the fastest time, so the value that's stored in our fastest time, to player prefs dot get float fastest time. So we're getting a float, that's the type we're getting, and it's stored under the key fastest time. Else or otherwise, we say the fastest time is just equal to float.maximum time. And what this is saying is that we give the float the maximum value it can hold. So that when you first run this game and it's never been run on, let's say a new user just downloaded this and it's never run on their computer before, they won't have a fastest time. So we need to set it manually for them. And the way we do that is just give it the maximum value that the float can have. Because then the first time you run the game, it's always going to overwrite that. The update function remains the same from the previous version of our script, and the on trigger enter sort of remains the same up until here. So we have an if statement that checks whether you've walked through a stop. And if you walk through a stop, the timer starts running. If you walk through an object tagged as end, the final time equals the current time. So whatever the time is on screen, that becomes your final time. And the timer running is stopped. But we do another if statement now. So we say if this final time is less than our current fastest time, so this value from here, if it's less than that, we've got a new fastest time. So we store that. And to store that, we just say player prefs dot set float. So this time we're setting the float. We give it the player prefs key, which is fastest time, and the data we wish to save in that key is our underscore final time. We then say player pref save, so we ensure that this now saves that player pref. And then we say fastest time is equal to player prefs dot get float fastest time, because we set our fastest time to this value we've just saved in the fastest time. And just for debugging purposes, we did a quick check which says debug.log fastest time plus fastest time. That can actually be commented out now because we know it works. We call a new function called display new time. So this display new time only ever gets called if the final time is less than the fastest time. And the display new time function does this. It sets our fastest time text dot text to the new fastest time plus fastest time dot toString, so we can convert the float to a string so it can display nicely within our UI text element. We then also say fastest time text dot game object dot set active is to true, so we make sure that actually tells the user here's the new fastest time. Otherwise, instead of calling this, if our final time is more than our fastest time, the fastest time dot text equals the current fastest time plus the fastest time. Again, convert that flow to a string, and again, all we do here is we just enable the actual text to be displayed on the screen. And that is something really, really simple. What we've just done here is so simple. We're just getting a flow and saving it. We're then comparing it, and if it's less than the current fastest time, we just get the new time and save that again. And then when we load the game the first time, we find whether we have that key. If we do, we get the float from that key and we save it as the fastest time. Otherwise, we just set a first value, and then after you play the game for the first time, it's going to set the new fastest time. Okay, thank you. Thanks for doing this extension task. I hope this helped, and I hope you have fun exploring different ways to improve your game. Thank you.